Last session we discussed pre-mechanical era. Let's we discuss about mechanical era. The mechanical age is the age when first noticed between our current technology and its forefathers. The mechanical age is defined as the period from 1450s to 1845, as there is a surge in interest in this field. Many new technologies are being developed. A mechanical age computer is one that made up mechanical component rather than electronic components such as levers, gears. The most common example are adding machine and mechanical counters, which increment output display by turning gears. Mechanical age of computer began between 1450s to 1850s, with the Industrial Revolution being the primary cause. Another reason was scientific renaissance that occurred at that time. Europe, America, and other countries revolutionized cultural, political, psychology, mathematics, astronomy, and part of science such as health science, chemistry, and physics during that time period. Same as immigration among the countries through the sea was developed. Otherwise, trade development and extensive mechanical knowledge. This developed area is extremely beneficial for developing the and beginning as the information and communication technology. Let's us first define the industrial revolution and the science renaissance. The industrial revolution was the transition to new manufacturing process that occurred in United Kingdom, continental Europe and the United States between 1760 to 1840s. The transition from hand to machine production methods, new chemical production and iron production process, the rise of steam and water power, the development of machine tools, and the rise of machinized factory system were all part of the transition. In this age has happened unprecedented population growth and rate of population growth. It's very helpful for computer development in history. Let's we discuss next pinpoint, that is renaissance of science. The science revolution was the series of events in the earlier modern period that marked the emergence of modern science. When the advance in mathematics, physics, astronomy, biology, including human anatomy, and the chemistry transformed the society ideas about the nature. We can pinpoint the point in mechanical age when the first printing press was invented. In the 1450s, John Gutenberg invented the printing press, and the first book ever printed was the Latin language Bible printed in Mainz, Germany. Let's begin with the what computer-based machine and equipment were invented in the mechanical era. The development of Napier-Bone is the next major step in the mechanical era. John Napier is the best known for inventing algorithms, which popularized use the decimal point in arithmetic and mathematics. Napier-Bone is manually operated calculating device invented by John Napier of Merkiston, Scotland, that used to calculate number, products and equation. Next invented machine is slide ruler. Slide ruler is mechanical analog computer that primarily used for multiplication and division, as well as function like exponent, roots, algorithm and trigonometry. It's not usually intended for addition or subtraction, which are usually done with other method. Calculating clock. Wilhelm Schachter is invented the first mechanical calculator, also known as the calculating clock. The device consisted of an upright frame that held a set of Napier bones and a mechanical counting device in the base. Nothing was known about this until recently. when a letter from Shekar to Clipper, discovered during the examination of paper of the astronomer John Clipper. This letter includes a rough drawing and a description of calculating machine. According to Shekard's letter, original machine was accidentally destroyed while fire. It's possible that Shekard built a second machine, but no trace of it has survived. Leonardo da Vinci drew plans for the calculator that were completed and correct enough for modern engineers to build a calculator on. In this age, next machine is Pascal calculator, also known as arithmetic machine or Pascaline, was invented by Blaise Pascal in 1642. In the laborious arithmetic calculation required by his father, worked as superior of taxes in Rouen, inspired Pascal to create a calculator. He designed the machine to directly add and subtract two numbers as well as perform multiplication and division through repeat addition and subtraction. Over the next 10 years, he built 15 of them. Next developed machine is step reckoner. Leibniz was an outspoken supporter of the binary system. Gottfried Wilhelm Leibniz, a German mathematician and philosopher, invented the step reckoner in 1673. Pascal's idea were expand upon the step reckoner, which performed multiplication by repeating addition and shifting. Leibniz was foresighted in recognizing the utility of binary system in calculating machine, but his machine did not use it. The step reckoner, on the other hand, represented number in decimal form. In this age, most popular machine is arithmometer. During the 18th century industrial revolution, there was a widespread need to perform repetitive operation efficiently. When the Charles Xavier Thomas de Colmar, the France built his arithmometer, the first commercial mass-produced calculating device. He efficiently met his challenger. It could perform addition, subtraction, multiplication, and division with same additional use interaction. It was extremely popular and sold for 19 years based on Leibniz technology. Jacquard-Loom machine, Jacquard machine, that considered most useful for computer technology. Punch cards were extremely useful for the development of computer during the age of mechanical and electromechanical significant inventors. This equipment served as the foundation for the development of input and output device. This device is controlled by small hole system, such as bell keys. During the evolution of computer science, that system converted input-output device into binary system. The Jacquard machine is the loom-mounted device that simplifies the process of producing textile with such as complex pattern. The device was remarkable in that it moved the design process from a labor incentive weaving stage to a card punch stage. In this video, we last discussed Jacquard loom machine. In the computer science, the main landmark is the difference engine and an analytical engine that was invented by great scientist Charles Babbage. We should talk about Charles Babbage. Charles Babbage was the polymath from England. Babbage, mathematician, philosopher, inventor, and mechanical engineer, invented the mechanical digital programmable computer. Some consider Babbage to be the father of computer, although Babbage's analytical engine contained all the fundamental ideas of modern computers. Babbage is credited with inventing the difference engine, the first mechanical computer, which eventually led the more complex electronic design. Babbage saw a clear need to design and build a mechanical device that could automate long, tedious astronomical calculation as founding member of the Royal Astronomical Society. In
1822.
1822, he wrote to Sir Humphrey Davy, President of Royal Society, about the possible of automating algorithmic cycles for use in mathematical table, especially navigation. Later that year, he read to the society a paper titled Theoretical Principles of Machinery for Calculating Algorithmic Cycles. It received the Royal Society first gold medal in 1823. The algorithmic cycles in use at the time were frequently fluid, which could mean the difference between life and death for sailors at the sea. And Babbage argued that automating the production of algorithm cycles, he could be ensure that their accuracy. With societies backing for his difference engine, Babbage approached to the British government for funding and he received the world's first government grant for research and technological development. It automated not use just one calculation to solve complex problems, but an entire series of calculation, a variety of variables. In other way, it went beyond the calculation. It difference engine like modern computer had a store, a place where data could be temporarily stored and later processed, designed to seal its output and soft metal, which would be then be used to produce a printing plate, as well as difference engine further developed as the analytical engine. Analytical engine. The analytical engine was to be the general purpose, full program controlled, mechanical digital computer with automatic operation. It would be able to perform any calculation that was given to it. There is no evidence that anyone before Babbage had even considered, let alone attempt to build such a device. The machine was designed with four components: a mill, a store, a reader, and printer. They are an essential component of the computer today. The mill was calculating unit, analogous to the modern computers central processing unit. The store was their data were held prior to processing, exactly analogous to memory and storage in modern computers, and the reader and printer were the input and output device. The project, like the difference engine, was far more complex than anything previously built. The store was able to large enough to hold 1000 to 50 digits numbers, which was more than any computer built before
1960s.
1960s. The machine was to be steam powered and operated by single attendant. The printing capability was similar ambitious as it had been for the difference engine. Babbage wanted to automate the process as much as possible, all the way up to printing tables of numbers. Another new feature of the analytical engine was the reader. On punch card, data were to be entered. Users would be use programming language similar to modern assembly language. Over 12,000 individual mechanical pieces weight over 15 tons and roughly the size of the small steam train engine. Speaking of steam, the machine was to be the powered by steam engine, which would be eliminated need for a human operator to turn a crank. Another thing is we should talk about Ada Augusta. Ada Augusta is the very first world programmer. Analytical engines algorithms were created by her. She proposed a machine that could do more than just calculate. She proposed machine that could be more than just calculate. She created first computer program, also known as the first algorithm. She was mathematician and writer from England. Miss Augusta collaborated with Charles Babbage to create the analytical engine. In this era, next invented machine is printing calculator, inspired by Charles Babbage difference engine. George Stewart and his son, engineer Edward Schwartz, designed and built a machine to computer tabular difference and print in the result. I believe you learned some knowledge from these videos about mechanical error. Let's we discuss about electromechanical error. Thank you.